हेलो एस्पायरेंट्स। तो कैसे हैं आप सब लोग? आई होप यू ऑल आर डूइंग रियली फाइन। वेलकम टू माय यूट्यूब चैनल दैट इज़ प्लांट साइंसेस विद ध्रुव। सो आज जो इंपॉर्टेंट टॉपिक हम कवर करने जा रहे हैं दैट इज ब्लेंडिंग ऑफ सीड लॉट्स विद पियर्सन्स स्क्वायर मेथड। लेट इट बी एनी एग्जाम, let it be JRF, SRF, state entrance exam, or even in many of the competitive exam, you will find a question based on this method. Most of the time, what students will do is to ignore this part or just think that it is really easy and we can do it. But when the question actually appears in the exam, there is a hell lot of confusion, like how are we gonna solve the questions based on this method. So in this video, we are gonna cover that thing. So let us first see what exactly is Pearson's square method. It is a simple procedure that has been used for many years and mostly when two or more ingredients are to be mixed. When it comes to the plant sciences, it is used for the reconstitution of seed lots of different germination percentage to achieve the seed lot with required germination percentage. So it can be used either for the two seed lots or even for the multiple seed lots. Also, another use case of this is when we have to calculate the nutritional requirement or the ration to be fed to the animal husbandry or different animals. At that time also, that ration portions are calculated on the basis of Pearson's square method. So in taking a close look at a square, several numbers are in and around the squares. So देखते हैं कि इसमें होता क्या है exactly. So ये बन गया अपना एक square. इसके आजू बाजू हो गए numbers. Let us consider numbers as A, B, C and D. The more important number, that is target, is the number that appears in the middle of the square. So let us consider this X. So this X will become our target. What is target? Target is nothing but the resultant number which we want. So that will come in the middle and that we call as the target. So when a question will appear based on this method, how to solve it? Let us learn this by solving an example. So let us read the question here first. What it says, cotton crop consists of two seed lots, seed lot A and seed lot B. They are having different germination percentage, 50 and 70 respectively. So we have to calculate the quantities of two seed lots to be mixed to get the 800 kgs of seed, fulfilling the certification standards. Now first let us see what is the crop. So it is cotton. For cotton, the minimum germination percentage as per ISTA certification standard is 65%. So this either it will be given in the exam or if they expect you to know this, then it won't be given in the exam. So you need to learn this standard germination percentage. So resultant we want is 65. This becomes our target number and it comes in the middle. Now what we have to do is we have two seed lots A and B that we are going to write here. Seed lot A and seed lot B. Similar thing we are going to do on the opposite side. Seed lot A and seed lot B. Germination for seed lot A is 70, that we will write here. And germination for seed lot B is 50, that we'll write here. Now we have to apply the diagonal rule. When considering for seed lot A, let us draw a diagonal over here. And here it will be 70 minus 65. Always remember, when you are applying this diagonal rule, you have to subtract the smaller value from the greater value, because these values can never be negative. So this point you have to keep in your mind. Then for seed lot A, let us draw another diagonal over here and it will come 65 minus 50. Again we are subtracting smaller value from the greater one. So answer here will be 15 and here it will be 5. So this answer will be in the parts. So when you will add 15 parts of seed lot A and 5 parts of seed lot B, you are gonna get the seed lot with 65% germination. But here they have asked specifically for the 800 kgs. So how are we gonna calculate that? Here first you have to do is the total of the parts. 15 plus 5 comes to total 20 parts. And now we have to do simple cross multiplication. Let us first calculate for the seed lot A. Here we can see for A, out of 20 parts, 15 parts should be there. So similarly, if we have 800 kgs of seed, then how many parts? So that we'll consider as X. Now just by doing simple cross multiplication, we will calculate x, that will be 800 into 15 divided by 20. 0 goes, 2 ones are, 4s are, comes to 40 into 15, that is equals to 600. Now for part B, out of 800, if A is 600, it is 200, but still just for the proof we will calculate that also. So what will be the value of B? 5 parts out of 20. So how many parts out of 800? Again x will be 800 into 5 divided by 20. It comes to 40 into 5, that is 200 kgs. So what will be our final answer? When we will add 600 kgs of lot A and 200 kgs of lot B, we will get 800 kgs of seed lot, that is our resultant seed lot with 65% germination. Now this we have seen when we have the two seed lots. What if they ask for the multiple seed lots? So let us now solve another example. Read the question over here also. The wheat seed was harvested in 6 different seed lots. Germination percentage for those seed lots are given here. Calculate the ratio of each lot to be mixed to get the final lot with germination percentage of 85. So here our resultant is 85, that is our target number. So we will write it here in the center of the square. Now we have 6 seed lots. Let us write in the left hand side A, B, C, D, E and F. Now germination percent of each seed lot is given. For A it's 80, B it's 65, C it's 70, D it's 60, E it's 90 and for F it is 88. Now similar thing we have to do on the right hand side of the square. A, B, C, D, E and F. Now again we have to use the diagonal rule, but here it is somewhat tricky to use that rule. So you should be really focusing on where the diagonal is going. So if we consider for A, see where the diagonal will go, it goes to F. So what will be the value of F? It will be 85 minus 80. Again subtracting the smaller from the greater. So here it will be 5. Then for B, diagonal comes to E. So E will be 85 minus 65. That comes to 20. Then for D, it will be 85 minus 70. That comes to 15. Then for D, diagonal is C. So it will be 85 minus 60. That comes to 25. Then for E, diagonal is B. 90 minus 85 again comes to 5. Then for F, diagonal is A. So 88 minus 85, that comes to 3. So this is the ratio which we have to mix in order to get the 85% germination. So how will we write our final answer? It will be in the ratio form. So A is to B is to C is to D is to E is to F. 3 is to 5 is to 25 is to 15 is to 20 is to 5. So in this ratio we have to mix the seed of these 6 lots in order to get the final seed lot with germination 85%. What if they ask now for specific amount, like for example if they have asked for the 1000 kgs, then again what we will do is the similar thing which we did in the previous example. We will calculate the total parts. So total parts here will be 20 and 25, 15, 5, 5 and 3, so it will be 73 parts. So out of 73 parts, for example, if they are asking for B, 5 parts are there, so for 1000 kgs how much it will be? So again x will become 5000 upon 73. So similarly you can calculate for the all remaining seed lots. I hope you have understand this concept of how to calculate the different amount of seed lots to be mixed to get the desired seed lot with desired germination percentage. So this is all about the Pearson square method for seed blending. If you have liked this video, then definitely do comment on this video, share this video, and most importantly subscribe it and make it reach to your friends who are preparing for the different exam. I'll be coming with more such important videos with the point of view of plant sciences, SRF and JRF. So keep following me. See you in the next one. Bye bye.